Hello friends, in today's question, from a solid sphere of mass m and radius r, a cube of maximum possible volume is cut. Moment of inertia of the cube about an axis passing through its center and perpendicular to one of its faces is, so I have to select one of these four options. So in this case it is given that from the sphere of mass m and radius r, a cube of maximum volume is cut. So let us say that the side length of cube is given as a. Therefore, we can say the diagonal length of the cube between the diagonal opposite vertices of the cube will be having a length of a multiplied by root 3. Okay, so we can say diagonal length for the cube will be equal to a root of 3. And for the cube to be having a maximum volume, for cube to have maximum volume, its diagonal length should be equal to the diameter of the sphere. The diagonal length for cube should be equal to diameter of the sphere. Therefore, the diagonal length of a cube is a root 3 and the diameter will be equal to 2r. So from here we can say that a will be equal to 2r divided by root 3, or it can be written as 2r root 3 divided by 3. Therefore, for the volume of the cube, volume of cube will be equal to a cube. Now using this relationship, we can say that volume for cube will be equal to 2r square root of 3 divided by 3 and its whole cube, which will be coming equal to as 8 r cube and square root of 3 divided by 27. Similarly, we can find out volume of the sphere. Volume of sphere, which we can write as V sphere, will be equal to 4 by 3 pi r cube. And from here we can find out its density. Mass is given as capital M, so we can say density of sphere will be equal to mass divided by volume of sphere, which will be equal to, this will be coming as 3m divided by 4 pi r cube. Therefore, we can find out the mass of the cube. Mass of cube, which is given as, let us suppose, as m cube. This will be equal to density, because the sphere as well as cube will be of the same material, so their density will be equal to same. So we can say this will be equal to density of sphere multiplied by the volume of the cube, so which comes as m cube is equal to, we have 3m 4 pi r cube multiply volume we already know is given as 8 r cube square root of 3 divided by 27, and r cube cancels out, this goes by 9 and this goes by 2. Okay, anything else? Sorry, 4 2s are 8, and this there was a mistake on my part. Okay, so this will be here 9, okay, because of the cube. And let me solve this again. So we get mass of cube is equal to, we have density of sphere, that is 3m divided by 4 pi r cube multiplied by 8 r cube, and this comes square root of 3 and 9. Now it is, so this 4 and 2 r cube goes with r, and this cancels by 3. Okay, so we get the mass of the cube, we get mass of cube will be equal to 2m root 3, and this will be equal to 2m root 3 divided by 3 pi, and we are supposed to find out the moment of inertia. So we can say moment of inertia for cube about the axis which passes through the center and is perpendicular to one of the faces. So that moment of inertia, if it is represented by I, this will be equal to 1 by 6 mass of the cube and side square. So we already found out mass of the cube, and we already know the, you can say, side of the square. So we can say moment of inertia will equal to 1 by 6, mass is given as 2m 3 pi square root of 3 multiplied by side is given as 2r square root of 3 and divided by 3 whole, this will be square. Okay. Now it is a simple calculation. So we can say our moment of inertia will be equal to 1 by 6 multiplied by 2m root 3 divided by 3 pi, and this will be equal to our 4r square and multiply by 3 and divided by 3. Sorry, 3 will be 9. So therefore we can write this will be equal to 3, and we are left with now 1 by, let me solve it, this will be m, and we have r square and multiply by, this will be 3, this will be coming as 4, and this will be 27 and root 3, and we divide and multiply by root 3. Pi is also there, so we are left with m r square divided by pi multiply by 4 3. This is 27 multiplied by root 3, and this goes by 9. So finally our moment of inertia I will be equal to 4 mr square, and this becomes our 9 pi root of 3. So this is the moment of inertia for the cube. This is moment of inertia for cube about axis through center and perpendicular to one of the face, and the option is our 4 mr square. So this is 4 mr square, and the denominator is 9 pi. Yeah, option number B is the correct option. So we can say that option B is correct. So this completes the question. Thank you.